Um, let's start by a story. I guess I guess it was 2009. We had been using a central version control system for a long time. That was SVN, and we were having lots of troubles. Like we were waiting and waiting for commits to arrive to the servers because our network was not very stable, and we were hating SVN, unfortunately. And during the collaboration, the cost of creating branches was very high. And if you would like to compare two branches, if your repository is big, then you had to wait a lot of time. And at the end, you notice that you were comparing the wrong branch, and you did the same for the right branch and wait a lot again. At that time, our technical leader suggested to move to Git. We didn't know that. We didn't know Git. And we investigated, we Googled, and we saw that Linus Torvalds, the name Linus Torvalds under name Git. Linus Torvalds wrote Git in a weekend. Interesting. And it's a distributed version control system. I don't know. I didn't know what is a distributed control system anyway. But if you see Linus Torvalds on somewhere, you might expect something cool, right? Because he is Linus Torvalds. So then we thought that hey, we messed up the system. That's why it's better to use another version control system. It doesn't matter if it's a Git or not. Let's move to Git. And in a week, I guess. We moved 250 million lines of code. That is 9 gigabytes of repository source code into Git. Wow, that's a lot. And we start to have troubles, new troubles, and we didn't know how to resolve it. So we searched for Google, and we didn't find any good solutions. One day, one of my friends screamed. He said that he lost his 3 days of work. And we looked at it, and we couldn't find any solution. We start to think about moving to another version control at that time, on that day. And the guy, my friend, wrote 3 days of work again. That's unfortunate. After that day, I start to think about Git a lot. I wanted to know Git more than any person in my company because I really want to help people, and I investigated. I read books. I spent nights, even weekends, for just practicing Git at my home, and I start to notice some harmful patterns. Those are harmful patterns while using it. Those are done by my colleagues, by other teams. Even while I'm a consultant in many companies, I saw many other teams interesting harmful patterns they use, and I call it Git Antipatterns. In that session, I will tell you 10 Git antipatterns, okay? Now let's find who haven't used Git before. Please show your hands if you haven't used Git before. Perfect, one guy. Congratulations. I hope you will like it. I hope you will like it. Okay, let me introduce myself very shortly. My name is Lemi. I'm from Istanbul. I'm an ex-Sony and ex-eBay Turkey employee. I'm the founder of a Turkish software craftsmanship community, and I really loved practicing. In fact, I really loved sharing my knowledge throughout my career. Okay. Yeah, let's start. So, I love Git a lot. It is not because Linux Torvalds has a name on it, because its internal structure is hot. It's very powerful, and we can see lots of magic behind. However, in order to feel comfortable while using it, you have to know the principles behind, and you have to know how Git behaves behind the scenes. And I will show you in a minute. Okay, the whole behavior behind. So let's start with an anti-pattern. First anti-pattern is what I call it dropish Git anti-pattern. So you add your changes, then you commit and you push. You commit and you push. If you push all your commits after you commit, then you are using your Git as if you are using Dropbox. And if you're using in that way, you can use Dropbox instead, because Dropbox is very stable, and Git, the full power of Git is not designed. It is not fully enhanced for using in that way. So just remember that philosophy. Git is very powerful, and you have to think before you push. I will describe the details later on. Let's learn how it works behind the scenes. When you learn it, you will feel more comfortable, I'm sure. First, okay, Git has two mechanisms for governing all those versions. The first one is there's a .git directory in your Git repository. In fact, we call repository to .git directory. When you see a .git directory, you can see that it's a Git repository, and in that repository, in that folder, Git stores files and folders and all the content in a compressed form. Git compresses all the content of files and directories and commits via zlib algorithm. Okay, and Git calls them as objects. And Git organizes all those objects in an interesting way. The power of Git lies behind it. So all objects are put in a directed acyclic graph, which means there is no circles and no bidirections. And Git keeps all the objects, all files. In fact, there is no object in there's no object database. There's no database in Git. Git keeps everything in a file system because Linus is a file system guy, he said in one of his conferences, and Linus, and Git keeps all objects and versions and manage all of them in a graph. I will show how that graph works very soon. So you want to version the changes, right? You have a project, you have packages, you have files, and if you want to version those files, you have to run the git init command. What Git does is it simply creates a Git repository, and it creates the objects directory inside .git directory, and then we call it an object database, and Git creates a cache, because Git only keeps the content. It does not keep the path, the path of your local system in the objects. Therefore, it keeps all the path and all permissions in a cache. That is the index file. Okay. And if you would like to create the same repository on the remote, you have to run the git init --bear. What it does is it creates the same content as in your .git repository on the remote. We call it as upstream. And if you want to add your changes, you run a git add dot command. It's a shortcut for adding all the files and folders to Git, and it simply adds your files and folders to Git. Yeah, git add simply adds your files and folders to Git. It creates objects, one object for your file and three objects, three compressed files, I mean, for the folders, for three different folders, and it keeps their paths and the the index binary file. And Git keeps the whole structure in a graph, as you see. It's really pretty that simple. So files and folders. Folders shows the files or the other folders, and files are the terminals. So remember, you cannot push or you cannot add empty folders in Git, right? Because Git in Git only the files are the terminals. That's the point. And you would like to commit your changes. Whenever you commit, commit is done in your local only, and only a commit object is created. It's lightning fast because Git only creates one simple file, nothing more, one. That's lightning fast. And Git also creates the master branch, the branches, and you have a head pointer, and if head pointer shows the same commit object as the branch, it means they are attached and they travel around the Git graph, the Git commit graph together. Okay, and for the second commit, you can see the evolution. If there's a change in your file, a new file is created, but if it's not changed, the references will be reused. And for the third commit, you can see that branch and head, they're attached and they move together. And new commits are created, new commit nodes are created, and they show the previous commit and the root folder. I mean, this is that simple. One day I was very curious about it, and I extracted like 10,000s of objects and prepared a graph, and I found a very similar graph like this. I mean, Git really behind the scenes uses those kinds of directed acyclic graphs. And you would like to push them to the server. So if you need to push, you have to add, of course, the URL of the remote upstream to your Git repository. And if you push, behind the scenes, Git uploads the objects into the upstream. It's a just upload command, and it's fully utilized. Therefore, it's pretty fast. All content is compressed into via Zlib library. And let's imagine that your colleagues also pushed to the remote repository, and you would like to get all those changes from remote. What you do is, first you can use a fetch command. Git fetch simply downloads all the objects from remote to your local. When you call fetch, your head pointer does not move anywhere. Only the tracking branches, those are the read-only branches representing the remote branches, only they move. They move to show the latest coming changes. And you can call git merge fetch head. Fetch head? Fetched head is an interesting hidden pointer as head. Git has in fact a kind of 7 or 8 hidden pointers. No one can see them, but they are there, and Git uses them for finding where for deciding how to move forward when a conflict happens, like after cherry pick, after merge, or after rebase. Okay. And you can run git pull instead. Of course, git pull is a shortcut command for git fetch plus git merge. But if you like to use rebase afterwards, after git fetch, you can run git pull dash rebase. Of course, that's also possible. Let's update the last commit. If you want to update the last commit, you can. Okay. I can see, but let's start again. Perfect. Yeah. Perfect. Okay. If you would like to remove the last commit or change your last commit, you can use soft reset or git commit -- amend. They are very similar, but they are not the same. There's a slight difference. However, when you run them, your last commit objects become unreachable in the object graph, and the entry in the index file will be removed. So you can see here, let's do a git reset -- soft hat tilde. You can see that your head pointer and the attached branch pointer move backwards, but the commit is there. In Git, nothing is lost. The only way to lose some kind of code is the hard reset, and I will come to that one. Okay, and you would like to squash your end commits, what you need to do? You can use reset. By default, reset command is mixed reset. Okay, you do not need to write -- mixed. Bare reset commit is a mixed reset, and when you do that, your last commit becomes unreachable, of course, but the commit, the entry for commit, and your files and folders on the last commit will be deleted from the index. What it means is when you do a reset, your changes for the last n commits become available in your source code as if they are newly happened. They are newly added, okay? And you would like to get rid of your last n commits. What you need to do is you can use hard reset, but with one exception. Hard reset removes everything, including the changes that you haven't committed yet. So your last n commits, the whole content and the content that you haven't committed yet are removed. Okay, that's the things behind the scenes. Okay, another antipattern. So version control systems are time machines. You should be able to jump back to any commit at any time, and after you jump, your application should work. Your commit should the source code that you jumped should compile. All your tests should pass, and your application should work. But normally it is not possible. In reality, people commit and push so fast, and they don't care about it. And whenever you have to go back in time, you look for a tag. We always jump back to tags. not commits. But Git is so powerful that that is not the right thing. Commits should contain some healthy source code. Okay. Here you can see a screenshot of a real commit graph, commit log, and my friend used the same commit message again and again and again for a week. And for the last commit, do you think that is the last commit for that task? No one knows. Maybe after few days, that guy could create a new commit and use the same commit message. We should change that behavior, okay? But I will come to that one, okay? I will have a proposal for that. Okay. We love branches. Branching mechanism is the most powerful feature of Git. Everyone agrees, I guess. However, long branches, I mean, long living branches, they are deadly. They are deadly creatures. So if you live in a branch for a long time, it means you will be in trouble. Not just for. I'm not talking about resolving the conflicts. It's more than that. Living in a branch or creating a branch is like leaving your home for a trip. If you come back after 3 days, like I will do, you will find your wife, your kids on the same apartment building. The city is almost the same, right? In 3 days. However, if you go back after 30 years, you might not find anyone else that you can remember. Like, we have to go back to our source branch as soon as possible. This is a real screenshot. So a kind of, it's a highway pattern, like 30 branches. They're waiting for a merge, and I don't know who will merge them, who are brave enough to merge them. Most probably they will live forever, or half of them will live forever. We should change that behavior, okay? I will talk about the cure later on. Okay. So, we have a continuous integration, right? We write tests, and every time we create a commit, our tests are run. Every time we push to remove, our tests are run, right? However, validation, there's a trick in the validation. So most of the time, our validation runs after we merge. After we think that our feature is okay, our feature branch is done, then we merge, we create a pull request, and it is accepted and reviewed and accepted, and it's merged to source branch, then the validation starts. And people start to test it and deploy it to test the environment. It's too late. If you are having the same behavior, it's too late for validation. Validation should be done before the merge, before you think that the feature is completed. Do you remember that graph, that thing, that diagram? It's Git flow. This is famous Git flow. I've been using Git flow kind of, let's say, 9 years or 2009. No, not 9 years. Since 2009. And we built all our branching mechanism on top of it. However, I start to feel that is not the right branching mechanism, because it leads it leads us to validate before the merge. Because you have a develop branch and a master branch, you create a feature branch. Everywhere is a branch, and there's no strict rule or there's no mechanism to push the developers to validate before merge or to have short branches. Okay. So, do you often need to merge and unmerge just before the release? I've been doing consultancy in many companies like banks and telecom companies, and most of them have a version 11, version 12, version 13, version 14 branches. And people, I saw a guy, he committed to version 14, even their current version is 10. So I said, how did you do that? Because version 14, I mean, seems to be deployed like 6 months later, but you created that feature in that version 14. And he said, don't worry, we use cherry pick. Cherry pick help. This is the most helpful comment for Git for developers. So there are some architects. They are the cherry picker guys. They know how to cherry pick each commit one by one, and they sit on the computer and check every commit and cherry picks and resolves the conflicts one by one. But that is a bad behavior. That is not sustainable. We have to resolve that behavior. Okay, like cherry pick. If you use cherry pick a lot, you will be in trouble after a short period of time, because you cannot live with resolving that conflicts in that sense. Okay. So, commit graphs. Commit graphs are there for developers because developers read commit graphs for understanding. They are not there just for showing the red, green, and purple characters. They are there for helping the developers. But how can a developer understand such a commit graph? There's a mountain pattern in the commit graph, highway pattern, so ladder pattern. So what is the source branch? When should we merge, and what is unmerged? Tons of tracking branches, tags, and such. One rule, if we need to state, is commit branches should be simple and clean as much as possible. Okay, so there are lots of antipatterns there. So what should be the cure? The cure for me is commit early, commit often, perfect later, and publish once. So you can commit early and often, no matter what, no matter it is your code is compiled or not. Do you need a versioning system? Do you want versions? Do you want to go back? Okay, commit, no worries, but do not push. Do not push. Wait a little bit. After you think that your code is compiling, your tests are passing, you do not need to wait for your feature to complete. It is important. You do not need to stay in a branch for a long time. You should not stay. It's a kind of task branch. Whenever you are ready, you commit. Perfect later and publish once. Okay, if you have a feature, if you have a feature, you have to split it into small tasks. Like in red green refactor, if you do TDD, you can commit after your refactor phase. And please do not push. And always regularly and continuously do git pull. But please git pull with Rebase, because with Rebase you can avoid duplicate commits anti-pattern. You might have some duplicate commits in your commit graph. That is important to avoid this. And okay. And if you need to push, if you already pushed, you should push after you pull dash rebase. I mean, if you do a kind of rebase, you have to force push, no matter what. it's important that you should not rebase on a shared branch. That's the statement, okay? And you can use git fetch origin master colon master just for synchronizing your source branch with one comment without checking in, okay? And afterwards you can squash them into one commit. I always advise squashing your commits. Squashing it is important because 99% of your time you won't need to jump back to your half-arsed commit. It is not your previous, if your previous commit is not working, no one will jump into it. So there is no need to keep the commits separated into many not working commits. Just squash them into one and then merge them. That's all. And merge them, and you will have a clean object graph or commit graph. Okay. In the end, trunk-based development simply is the cure for all these anti-patterns. But one thing is very important. You have to release often and you have to release frequently. Like 5 times a day should be your target. You should delete your branches after merge. No need to keep them because you should write detailed commit messages. No need to keep the merged branches, and you should use feature flags. Feature flags are very important in trunk-based development. If you do that, you will have a master branch and you will have a feature branches, short task branches, what I call. Okay, a new anti-pattern. Okay, everyone loves user interfaces. However, in order to learn Git in advance, in advanced form, you should use terminals. So believe me, using terminals is very important for using Git. Even aliases are dangerous. So keep a few aliases for yourself and use Git commands bare in order to, in bare form, in order to learn Git better. And stop adding all your changes to commit every time. You refactor, you fix a bug, and you do some changes for your latest feature. And what you do is you add everything and put into your commit. It is not the correct behavior because every commit should have a specific context and scope. So that's why you can use a few tricks. One is if you are using JetBrains IDs, you can use local change set feature. So in that feature, if you have changes, you can select them and you can separate your local changes even before you add. Then you can add them separately. You can group them separately. That's a fantastic tool, that's for sure. Or with a partial add, for example, if you have 2 changes in a file, but you would like to add only the first one or the second one, you should not use git add file name. Git add -p is your friend. Like with that one, you can easily here, for example, in readme.md file, there are 2 changes and you would like to add only the second one. What you need to do is first, do you want to add these changes? No. Do you want to add that change? Yes. The second chunk, the second change, it is added. And when you do a git status, you see that the same file is shown in modified and edit form and staged areas. Perfect. Okay. Commit messages are important because developers read it, and developers read it for understanding it. However, it's hard. It's hard to keep them understandable, keep them useful. So what we need to do? Hopefully we have Git now has a template mechanism. So you can use Git commit templates in your local and write good Git commit messages. Like here, if you use Git template, Git commit template, you can see here the template in blue. You can easily look at them and write your commit under them. And it's, for example, you can put, remember your Git, the standard of your Git commit messages should obey those rules, and you can put them to the template too. And I love that anti-pattern, that by rebase conflicts. Rebase conflicts is very popular because if you do a rebase, you die, because there are always, you have to resolve conflicts, the same conflicts again and again and again. The same conflicts, you have to resolve it. Hey, you think that, hey, I resolved it already, why I need to resolve it again? And endless rebase conflict resolution practices occur in your lifetime. So what you need to do? We have to know how rebase really works. Okay, when rebase really works, it's that simple, right? You change the base of C5 from C3 to C7. However, we have to slow the whole procedure a little bit down and see what happened behind the scenes. Let's see what happens. And first, the first commit in your feature branch C5 is committed to after C7, which means if there's a conflict, you have to resolve it. And then C6 is committed, and if there's a conflict, you have to resolve it. And your topic branch is moved, and ORICAT is used by the rebase and merge, so you don't need to, you won't see it at all. And let's remove it from the graph. Then what happens? Rebase completes. Rebase done many commits. Rebase does many commits one after another. That's why if you have a long branch like this and you would like to rebase it on another branch, you have to resolve the same conflicts again and again. You might resolve the same conflicts again and again. So what you need to do in that situation? In that situation, you can use merge. That's fine. Or you can use merge -- squash. What it does is it squashes your all commits in your feature branch into one commit and puts to the top of your source branch. Pretty cool. Or you can squash and rebase. You can use interactive rebase, or simply you can squash it by reset and put on top of your source branch. There are lots of anti-patterns in Git. This is just 10 of them. Lots, a lot. Let's recap. I have 5 minutes. Let's recap. Okay, what was really happened at that time? You remember my friend lost 3 days of work? If Git is that powerful tool, what has happened at that time? We have to identify it. As in fact, I couldn't remember because at that time I couldn't find a solution. But now I can imagine what can happen. For most probably, my friend could check out into a commit or into a tag. If you check out into a commit or into a tag, you fall into detached head state, which means your head pointer and the branch pointer, they are detached. They will live separately. So You can that can happen for a few times. If you have a git rebase and the conflict happens, you can find yourself in a detached head state. And if you check out into a tag or into a commit, okay? And my friend didn't know that, poor my friend, and he developed 3 days and commits lots of changes. And one day, another friend most probably said him that you should go back to master and to fix a bug. And my friend, hey, checks out to master branch. And what happens? Hey, all his 3 days of work disappeared. And but they are there. They are they are there, but no one can find it. In order to find it, he should have used git reflog. Git reflog keeps the movement of your head pointer, and your git reflog displays different entries than mine because this is your head pointer, and in my local my head pointer behaves differently. That's why that my friend should do a git reflog and try to identify one by one the commit ID, which ID is the last one, and if he if he created, I mean, a temp branch for the last commit, he could have got everything back, but we didn't know that, unfortunately. Um, but anyway, if you think that your code has lost in Git, take a deep breath, okay? Because you have a git reflog or git fs check, so you can find them because nothing will be deleted in Git except the hard reset, of course. Thanks a lot for listening me. Thank you. I don't know if you have time for question, but 2 minutes, okay. Oh, you have one. Yeah. Uh-huh. I see. So the question is, you're using Git bisect uh, and your broken commits. Uh-huh. Ah, I see. I see. So the question is,
how to deal with it, or have you
okay,
experienced
okay.
such
In
problems?
fact, I haven't experienced that one, but I will be happy to discuss with you after the talk. Okay.
Okay.
Okay. Thank you. And I have one last minute. Okay.
Hi. Good talk about Git there.
Thank
It
you.
was great. With the Git reset hard, are you sure that the reflog still doesn't keep track of your head? I'm sure you'll lose your stage changes and stuff, but if you do a Git reset hard a couple of commits back,
Yeah.
I'm pretty sure the reflog will still let you go back to those other commits.
Yes, yes, definitely. If you do git reset, your head pointer moves backwards, and git reflog keeps the IDs of the previous and the current commits
Yeah.
into the reflog, and you can check them and create the temp branch and
Yeah,
get
yeah.
back.
So you lose your current changes and your stage changes, but you don't lose any of the commits that you're going back.
For the stage changes, you cannot see in reflog because there's no
They're gone.
commit at all.
Yeah.
Yeah, that's the point.
Great,
Okay,
thanks.
okay, thank you. Okay, okay, thanks a lot, guys. Have a nice conference.